here we are talking about integers and floating points. These are a concept in programming languages and in Python called type. Variables and constants have a type. We can see that if you say 1 versus 1.0, they have different, it works different, it functions differently. And so Python keeps track of both variables and literals/constants and having them have a type. And we've seen this, right? Now the interesting thing is Python is very aware of the type and can use the same syntax to accomplish different things. So if we look at this line here where we say dd equals 1.4, well, it looks at the 1 and looks at the 4 and says, oh, those are two integers. I will add those together and give you a 5. So it gives you an integer, and an integer comes back. Okay? And then EE equals hello plus there. Well, these are two strings, hello and there. And it says, this must be a concatenation. Right? So I'm going to concatenate those together because those are strings, and I know how to concatenate strings, and that's kind of like string addition, right? And so we see hello there as a result. Now the interesting thing is, where did this space come from? Let me change colors here. Where did that space come from? Well, the plus does not add the space. There's a space right there, and that's the space. So I concatenated hello space plus there, and that's how I got hello there. But the key thing is this plus operator, clear. This plus operator looks to either side and says, oh, they're strings. I think you mean concatenation. Here, it looks either side and says, oh, those are integers. I think you mean addition. So Python is very aware of type, and type informs Python what you really mean. And so it looks like those are kind of the same, but they're quite different operations. So the type can get you in trouble. Remember, Python is looking at the type. So here we have a little problem. Our first traceback. First of many tracebacks. So here we have EE, which is hello there, which is exactly what we did. This is a string and this is a string, so EE should be a string. And then we try to add 1 to it. And again, Python is saying, oh, I see a plus sign here. So I'm going to look over here. Yeah, that's a string. And we'll look over here, and that's an integer. It's like, ah! And this is a traceback. Now, here's a good time to talk about tracebacks. Tracebacks, I color them red because you might think that Python dislikes you or thinks that you're, unworthy of its brilliance. And certainly the way these things are worded, it sounds like, you're being scolded. It's like, hey, type error. You cannot concatenate stir and int objects, right? I'm scolding you. You're bad programmer. And it does feel a bit like you're scolded. But if you go back to Lecture 1, this is also the moment where really we shouldn't think of this as like scolding. We should think of this as Python sort of asking for help. It's like, wow, you gave me this line, and I, Python, have no idea. In all your greatness, could you give me some possible clue as to what you really mean for me to do, because I'm so lost, and given that I'm Python and I'm lost and you are the only purpose for my existence, I must stop until you give me better guidance. So don't look at tracebacks as scolding. They sound like scolding. I'll stop coloring them red after a while. So if Python is so obsessed with the type of things, you should be able to ask Python what the type of something is. And so there's a built-in function called type. This is part of the Python language. Type parenthesis, and you can put a variable in here. What's the type of the variable EE? And it says, oh yeah, I know what that is. That would be a string. And then you can also put a constant in here and say, what's the type of quote, hello, quote? And that's a string too. And what's the type of the number 1? Well, that would be an integer. So it's picky about the type, but it'll also share with you what it believes the type is. And there's several types of numbers. As I've already mentioned, there are integers, which are the whole numbers. They can be positive and negative and 0. And then there are the decimal numbers, the floating point numbers, like 98.6 or negative 2.5 or 14.0. Python knows these as well because it does division different if it's presented with two integers, or an integer and a float, or a float and a float. And so here we have x is 1, and we say, what is it? It's an integer. And we say it's 98.6, and we say, well, what's that? It's a float. And you can ask for both variables and constants. So what's the type of 1? It's an integer. And what's the type of 1.0? And it's a float. You can also convert types. It has a bunch of type conversion functions built into it. So there's implicit conversion going on when you're sort of saying, divide an integer by a floating point. It says, okay, I look to the sides and I will make the conversion for you. But you can also be explicit. So in this case, we're going to say, take this 99 and convert it to a floating point version of itself, which is 99.0, and then do the division. So Python looks out here and goes, oh, after that's a float, and that's an integer if I look over here, and then that means that the result is a float, and the division is done as a float. So we are force converting the 99 integer into a 99.0 float. And we can even do this and just stick it in a variable. So we can put 42 in I, and that is an integer. Then we can say, hey, convert float that I into a float and stick it into the variable f. And so we can print it. And now it's 42.0 instead of 42. Right? They're not the same. They're both kind of 42, but one is a floating point 42 and the other is an integer 42. And we can ask, and that is a float. And you can also do the same thing in the middle of a calculation where you have 1 plus 2 times float of 3. This float is done quickly. So the first thing that happens, this is 1 plus 2 times 3.0, 0.0 over 4 minus 5. So the first thing that happens is these floats are done because they're parentheses, so they matter. So this is a built-in function called float that takes as its argument a non-floating point number and gives you back a floating point number. We'll talk more about functions in Chapter 4. You can also convert between strings and numbers. And if you recall, we did the example where we took a string. In this case, I'm being a little confusing because I'm making a string with the characters 1, 2, 3. Now this is not the same as 123. This is a 3-character string with 1, 2, 3 in it. And I can ask what kind of thing is in there, and it says, oh, there's a string in there. I know about that. And then I can try to add 1 to it. And it seems intuitive that, quote, 1, 2, 3 plus 1 would be somehow 124. But it's not. Python takes a look at the plus and says, oh, there's a string on that side and an integer on that side. I am going to freak out and tell you that you cannot concatenate a string and an integer. Okay? But there is an int function that converts various things, including strings, to an integer. So we can give as its parameter, its input, the string value, then it converts it to an integer, and then we'll put the result in the variable ival. We can ask what the type of that is. It's a integer, and now we can use it in an expression, print ival plus 1, and so now Python looks to both sides, sees an integer, and gets 124. Voila. Now, if I make a new variable and I stick hello Bob in it, and I say, hey, let's convert hello Bob to an integer, as you might expect, it blows up. And it says invalid literal for int. These tracebacks, again, once you kind of get used to the kind of harsh wording of them, because they're not saying sorry, comma, they're trying to tell you what's going on. So cannot concatenate string and integer, and invalid literal for int. It's trying to be as helpful as it possibly can be to give you a clue as to what to fix. So again, not scolding. Okay, so that's variables and types and type conversion. Now we'll talk a little bit about user input. And there's a function that's built into Python called raw input. And what happens when raw input runs is it has as one of its parameters a prompt, which is something that shows up on the screen. Who are you? And then it waits, sits and waits. It says, what next? And then you type a string, and then you hit the enter key, and then whatever you typed here goes into a variable. And it is a string, and then you can use it. So I'm going to print the string welcome, comma, so that means I'm printing two things now, the comma adds a space between welcome and then nam. And so welcome is a literal, and then Chuck is coming from this nam variable. So this is a 2-line program, and I think this is one of your assignments actually to, well, it's one of the exercises in the book, to prompt for a user's name and then welcome them. Okay? So raw input is a function that issues a prompt, waits, and then takes whatever string that's entered and then returns it and then puts it into that variable. So now we're going to create kind of the first useful program. It's not a powerful program. It is an interesting problem of the fact that for some reason there's a difference in the numbering scheme of United States elevators and European elevators. European elevators, the floor that you walk out on is the 0 floor. The floor above that is the 1 floor, and the floor below that, the basement, is the -1 floor. And so you walk in and you can either go up the elevator or down the elevator. Of course, in the United States, the floor that you walk in is the 1, and then there's the 2 floor above that, and then there's like the basement. So this is the imagination that the Americans have as to how to number floors. Right? The Europeans go 0, 1, -1. So children who go to hotels learn instantly the notion of 0 and the notion of positive and negative numbers and the symmetry between positive and negative numbers. I mean, I just wish the United States hotels would switch to this to teach young people 0 immediately and negative numbers. So we somehow think that numbers all in the United States start at 1, and then there are no negative numbers. There's the basement. I wonder why that is. But whatever. For people who travel a lot, they may be confused by this. They need a way to convert back and forth between the U.S. and European numbering system. So this is a simple program that demonstrates a real classic pattern of input, processing, and output. It's just 3 lines, but it has the essential things that all programs that are useful, they generally read some data, do some work with the data, and then produce some kind of results. And so the first line is a raw input that effectively puts out a prompt, and then it waits. It says, please enter your Europe floor. It sits there. We type a 0. Then 0 goes into imp, but it is a string. It's not a number. It is a string. So we can't add to it. But we can take and convert it to an integer with the int function. Int of imp. That's a string being converted to an integer. So now it's a real numeric 0. And we can add 1 to that. And we sum that together. And we put it in to the variable USF. And then we print US floor, comma, and then whatever the variable for USF is. And out comes US floor 1. So we've written a very simple elevator floor conversion from a European floor to a United States floor. Don't ask about negative numbers. It's not really good at that. But from 0 and positive numbers, it works great. So another thing to think about in any programming language is comments. Comments are like commentary, and basically it's a way for us to add notations for ourselves or for other humans interspersed in the code. And so in Python, anything after a pound sign is ignored. You can have a pound sign at the beginning of the line and then the whole line is ignored. There are 2 or 3 reasons why you can do this. One is sort of like paragraph headings, where you can say what's going to happen in English or your language. And you can write documentation that says this code was written by Charles Severance, December 2010. And you can also just hide a line of code to test and turn it on and off without actually deleting the line of code. It's a real common thing in debugging. So for example, here is the program that we've been playing with. This is our word counting program that we've been talking about from the beginning. And here is an example of 4 comments. 1, 2, 3, 4 comments that basically tell us what these paragraphs are going to do. Now, they don't have any effect on the program whatsoever, but this one says get the name of the file and open it. Kind of helpful, right? Count the word frequency. That's what this little bit does. Find the most common word. That's what this little bit does. And all done, print this out. So it's really can be very helpful just to add a little tiny bit of stuff. You don't want to overuse comments. You don't want to say like x equals 12. Take 12 and put it into x. Sometimes people teach you and try to say, oh, you need one comment every 3 lines. I don't believe in any of those rules. I basically say, if it's useful to describe it, then describe it. So that's comments. So some operators apply to strings. We've already talked about plus. It's kind of silly, although useful in places. You can actually multiply strings, where this is the asterisk looks and says I got a string and an integer, and it prints out the string 5 times. Not a lot of use for that. Now, let's talk a little bit about choosing variable names. This is something that is really confusing. So I said like x equals 1, x equals x plus 1. What does x mean? And the answer is, it doesn't mean anything. I chose it. I wanted to make a variable, and so I picked x. We pick x a lot, probably because we learned in algebra in 6th grade that x was a variable. So, and it's short, and so why not call it x? But as your programs get larger, this gets kind of frustrating to have all your variables like x and y and z. And so the notion of mnemonic, it means memory aid. We choose our variable names wisely so they remind us of what the variable's going to do internally. And so as I go through this lecture, in the beginning, if I choose a variable that's too clever, you're going to think that it's part of the language. And so I sort of switch back and forth between well-chosen variable names and stupid variable names to kind of re-emphasize the notion that I can choose. Mnemonic is a good practice. Okay? So here we go. Let's take a look at a bit of code. So the question is, what is this code doing? What will it even print out? Is it syntactically correct? Now you could probably cut and paste this into Python and figure out that it is syntactically correct. There are 3 variables. This one here and this one here match. This one here and that one there match. And these 2 match. So it's taking these 2 numbers and multiplying together and then printing out the product of the 2 numbers. If you're real careful and look at every character. Now, this would be called non-mnemonic variables. They're really messy. Now, Python, it's happy because all it wants is to say, oh, here's the name that I, the programmer, decided I wanted to call this piece of memory, and I'll refer to it down here. Okay? And so Python's happy. Now, if you hand this to another human being, they're going to be really unhappy because they're going to be like, what are you doing? So one better way to write it would be to make the variables very simple. And then cognitively, we humans can figure out which is which. Because again, it's still only about matching. The A has to match the A, the B matches the B, and the C's match. It's actually the exact same program. A equals 35, B equals 12.5, C equals A times B, and print C. It is these. Python sees these as the same program. It doesn't care what we name them. Now, a human will be much appreciative if you say, here, you can either have this one or this one. This one will make them a lot happier. Woo. Okay? So that is certainly cognitively easier, but it's not really giving you any sense of what's going on here. Right? So an even better way to write this exact same program to do the exact same thing would be to choose variables named hours, rate, and pay, if indeed that is what you're doing. Now you can look at this and you go, oh, well, shoot, 35 is the number of hours, and 12.5 is the rate, and the pay is the number of hours times the rate, and then we're going to print out the pay. That makes a lot of sense. So this is really a awesome and wonderful characterization And this, if that's what you're doing, and if those are hours, rate, and pay, it's a great thing to name your variables. But this is where beginning students get confused. And so sometimes I'll write it this way, and sometimes I'll write it this way. Because you look at this until you get a little more sophisticated, a little more skilled, and you say, like, does Python know something about payroll? Is hours a reserved word? Is rate a reserved word and pay a reserved word? Are these things that Python knows about? And the answer is no. Python sees these three programs as exactly the same name. It's just this person really made a very bad choice of a variable name. This person made a less bad choice of a variable name. And this person made a really awesome choice of a variable name. So the only difference between those two things is style. They are the exact same program. And Python is equivalently happy with these. But humans are most happy when the variables are easy to remember and they are somewhat descriptive of what their expected contents will be. That's mnemonic, to help you remember what you were meaning to do when you write the program. This is still a bit cryptic. Having these really short one-character variable names is still a bit cryptic. So, you have a couple of assignments at the end of the chapter. One of the assignments is to write a program to prompt the user for hours and rate per hour and compute pay. So I won't do this here, but just a couple of sort of things. You're going to be using raw input. But remember that hands a string in. So you're going to have to use float, the function, to convert it to a floating point number so you can actually do a calculation. And then you're going to have to use multiplication and print. So multiplication and then print. So it's some combination of raw input, float, multiplication, and print, constructed to make your program do exactly this. So this is the end of Chapter 2. We talked about types, reserved words, variables, the mnemonic, how you choose variable names. We'll hit this a couple more times because choosing variable names is always problematic. Operators, operator precedence, which just means like does multiplication happen before plus, parentheses. Integer division is a little weird because it truncates, right? 9 over 10 equals 0. That's the integer division truncating. Conversion, this is like the int, float, and then user input, which is raw input, and then comments, which are ways for you to add human readable text to your program. Okay? See you next lecture.